All right, this is the final exam review for Math 110, picking up with number 34. Divide the following using synthetic division. So we've got 3x cubed minus 2x squared plus 7x minus 5 all over x plus 3. All right, so I've written this down here, and synthetic division is where you can just pay attention to the coefficients of the polynomial that you're dividing, and the opposite of what's with the x. What's being subtracted from x is actually a negative 3. So we put that negative 3 outside the division symbol. And the coefficients of the polynomial, making sure there's no powers of x missing. We've got 3, 2, 1, 0 powers of x. So we're good. So just write down the coefficients, 3, negative 2, 7, and negative 5. All right, then you leave a space and draw a line. First step is to bring down that first number. Then you multiply that number times the number out here. 3 times negative 3 is negative 9. And then you add vertically. Negative 2 minus 9 is negative 11. And then you multiply that number times the number out here. Negative 11 times negative 3 is positive 33. And then you add, plus 7 is 40. And then you multiply, times negative 3 is negative 120. And then you multiply and you get negative 125. And that last number is your remainder. And the numbers before that are the coefficients of the quotient, which is always 1 degree down. If you divide a cubic by a linear first degree polynomial, you're going to get a squared polynomial, quadratic. So this quotient is 3x squared minus 11x plus 40. And then you've got a negative remainder, so I'll just write minus, and you put the remainder over the divisor, which is x plus 3. And there's your answer. All right. Number 35 says use the remainder theorem to evaluate f of x equals 2x cubed minus 4x squared plus 3x minus 1 at f of 2, at x equals 2. So we're going to take this polynomial, f of x equals 2x cubed minus 4x squared, I'm writing it down now, plus 3x minus 1, and we want to calculate or evaluate f of 2. All right, sorry, I wasn't pointing that correctly. Okay, so f of 2, of course, we all know one way to do it is to just plug 2 in, right? You can calculate f of 2 that way. That's how we usually do it. But the remainder theorem says that you can also use synthetic division. And the remainder, whatever you get for the remainder here, is the function value. In fact, this synthetic division that we did for number 34 tells us that f of negative 3 is negative 125 for f of x equal that polynomial. So here what we're going to do is we're going to take the coefficients of f and put them inside the division symbol. And we're going to put a 2 out here. So the coefficients are 2, negative 4, 3, and negative 1. Just ignore the dog barking. Leave a space, draw a line. Bring down the 2. Multiply 2 times 2 is 4. Add, you get 0. Multiply times 2 is 0. Add, you get 3. Multiply times 2 is 6. Add, you get 5. And that 5 is your answer. That's what f of 2 is going to be equal to. You can always check it by doing it the old-fashioned way. 2 times 2 cubed is 16. 4 times 2 squared is 16. 3 times 2 is 6. Minus 1. 16 minus 6 is 0. Plus 6 minus 1, sure enough, is 5. But it's just a slick application of synthetic division. Of course, this also shows us that if we were to divide this polynomial, 2x cubed minus 4x squared plus 3x minus 1, if we were to divide that by x minus 2, we would get 2x squared from the 2 right there, plus 0x plus 3, so just plus 3, plus the remainder of 5 over x minus 2. Right? So depending on what they ask you for, there's different applications of synthetic division. In all of these cases, because the remainder is not 0, you can see that we haven't found any factors or any zeros of these polynomials, but we've divided and we've found some function values. All right, so the remainder, when you divide by x minus 2, is the function value at x equals 2. All right, so then the other application is to determine if a number is a 0 of a polynomial. So that's where you're looking at, is the remainder 0 when you divide, in this case, by x minus 4. If you get 0 for remainder, then that means x minus 4 is a factor, and then x equals 4 would be a 0. Okay, so this polynomial is f of x equals x cubed plus x squared minus 19x minus 4, and the question is x equal 4 a 0? And the definition of 0 is does x equal 4 make f of x equal 0? That's the same question. In other words, is f of 4 equal to 0? All those three are the same question. That's why it's called a 0. In fact, one more thing would be, is x minus 4 a factor of f of x? So those 4 questions are all asking exactly the same thing. And to answer it, we can divide using synthetic division. So make our division symbol, put the coefficients of 1, 1, negative 19, and negative 4. And none of these polynomials have had any terms missing, so that's good. You're always going to have one more number than the degree. If it's a cubic, you should have 4 numbers. If it's a quadratic, you should have 3 numbers, and so on. All right, we are dividing by x minus 4, so we put a 4 out here. All right, leave a space, draw a line, bring down the 1. Multiply times 4 is 4. Add 1, you get 5. 5 times 4 is 20. Add, you get 1. 1 times 4 is 4. And add, you get 0. So the answer to the question is yes. And in fact, then we've got a quotient of x squared plus 5x plus 1. So that means we actually have factored this polynomial to that quadratic, that quotient, times the divisor of x minus 4. And here's where, if you wanted the other zeros and the other linear factors, you would have to use the quadratic formula on this guy, because that doesn't factor. But if you use the quadratic formula, you could find the other zeros and the other linear factors. In fact, let's do that. Let's see. X squared plus 5x plus 1 equals 0. X equals, quadratic formula is negative b, which would be a negative 5, plus or minus the square root of b squared, which is 25, minus 4 times a times c, which are both 1, all over 2 times a. So that's going to give us negative 5 plus or minus the square root of 21, excuse me, all over 2. All right, so we've got some irrational. They're real numbers. They're not imaginary, but they are irrational. You can't really do anything with that besides approximate it on a calculator. So then if you go over here, you could break this down into linear factors, which are just x minus each of those. X minus negative 5 plus the square root of 21 over 2. And x minus negative 5 minus the square root of 21 all over 2. And x minus 4 are the 3 linear factors of that polynomial. So it actually has 3 x-intercepts. If you were to graph this, let's do that. If we were to graph this polynomial, let me clear out my calculator, go to graphing, and clear that out. We've got x cubed plus x squared, x squared, minus 19x minus 4. And if I graph it with a standard window, oops, sorry, let me make sure you can see that. X cubed plus x squared minus 19x minus 4 is the polynomial. If we graph that, just with a standard window, we can see it comes through the x-axis right about here, right about here, right about here. This one looks like 1, 2, 3, 4, x equals 4, the 0 that they had us check. So that's in fact another way that you can look to see if it looks like a number is a 0 is if it's an x-intercept. And you can even check that by going second calc value and evaluate the function at x equal 4 and see that you get y equals 0. These other two zeros are not integers, but you could find them approximately by using second calc 0, where you give a left bound. Let's see, to the left of this one would be 1, 2, 3, 4, 5, 6, negative 6. And a right bound would be negative 3, just anything to the right of it. Double check that that's where you want the calculator to look for it and hit enter. And there's an approximation of negative 4.791. The y coordinate is 2 times 10 to the negative 12th, which is very, very close to 0. So negative 4.791 is a good approximation for one of these zeros here. Let me write that down. I'm just going to write it here. We'll write it over here. So approximately equal to negative 4.791. And then the other 0 on here we can approximate. It looks like it's between, well, for sure between negative 1 and 1. So we can use those as left bound and right bound. You go second calc 0, left bound negative 1, right bound 1. Try to get that glare off of there. There we go. So it's in there somewhere. Hit enter for a guess. Negative 0.2087. So approximately, here, I'll write it up here, approximately negative 0.2087. I'll approximate as 0.209, 3 decimal places. So those are approximations of those radicals. And one more thing to check that, let's just type in the radical. We had negative 5 plus the square root of 21 all over 2. There's the negative 0.2087. And then let me do second enter to pull that same thing up and then just arrow back to change that to a minus. And there's the other one, approximately negative 4.7991, rounded to 3 decimal places. So those are the other two zeros in exact radical form and decimal approximation form. Of course, when you're giving the factors, you always want to put them in exact radical form. All right, so we did more than what was asked for here, but I think it's good to review how you can break a cubic down into its 3 linear factors. First, by finding a nice one, by looking at, where's an x-intercept. In fact, even if they hadn't given us x equal 4, we could have seen it right here as a potential x-intercept, potential 0. When you divide it out, you see that for sure it is a 0. You see what the quotient is, and then you can use the quadratic formula on the quotient to get the other two zeros and the other two linear factors.